In this segment, we're going to talk about mass and matter. Mass is a measure of the amount of matter making up an object. But what do we mean by matter? Matter is that which occupies space and possesses rest mass. So now, what do we mean by rest mass? Rest mass is the mass of a body when at rest. So basically, matter is something that occupies space and has mass. The most common phases, or otherwise known as states, of matter are gas, liquid, and solid. So matter is that which occupies space and possesses mass, and common phases of mass are gases, liquids, and solids. So you can see that the main difference between these phases of matter or these states of matter is density, where density is the mass of the object divided by the volume of space it occupies. So the more mass an object has, the more dense it is. So a solid is much more dense than a liquid, and a liquid is much more dense than a gas. So you can see that the common difference between the different states or phases of matter is density. Objects that are more dense, such as a solid, have more matter. Objects that are less dense, such as a gas, have less matter. So if gases, liquids, and solids are common phases of matter, then what makes up these gases, liquids, and solids? Well, the answer to that is going to be atoms and molecules. And an atom is made up of particles, such as protons, neutrons, and electrons. Now, there are two definitions for protons. Protons are positively charged atomic particles contained in the nucleus of an atom. The second definition is that a proton is the nucleus of a hydrogen atom. So this second definition is special because the hydrogen atom is unique in that the only atom or the only particle in the center of the nucleus that makes up the nucleus is the proton. Now, before we explain the nucleus, what we mean by the nucleus of a hydrogen atom, let's go on to neutron. A neutron is an atomic particle with no charge, and it has about the same mass as a proton. So the nucleus of an atom is the central core of an atom that contains protons and neutrons and carries a net positive electric charge. So let's look at an example. Let's look at a helium atom. And let's only focus on the nucleus. We're going to draw protons as a red ball, a red circle. And since they have a positive electric charge, I'm going to put a plus sign on top of the red ball. Let's let neutrons be yellow balls. And since they have no electric charge, we won't put any plus or negative symbols inside the ball symbol. Now, in the nucleus of the helium atom, there are 2 protons and 2 neutrons. And since the proton and the neutron have about the same mass, I drew them the same size. So as you can see in the nucleus of our helium atom, we have 2 protons drawn red with plus symbols and 2 neutrons drawn yellow. And they're bound tightly together in this region called the nucleus. Now, surrounding this nucleus is concentric rings, but I only drew 1 ring. And in this ring, which is representing an orbit around the nucleus, we will find the electrons. Now, electrons are low-mass atomic particles carrying negative charges. This is negative electric charge. Now, what do we mean by low mass? Low mass, in this case, let's think of a pea, of a vegetable, a pea. And when we compare that to a proton or a neutron, think of a proton or a neutron as a bowling ball, really heavy, and the pea is really tiny and light compared to the size of the bowling and mass of the bowling ball of the proton and neutron. So we're going to draw the electron as a blue dot. So you can see barely see my blue dots on my orbit going around the nucleus of the helium atom, and there are 2 electrons. And to make them more clear, I'm going to put lines through them because they are negatively charged. So we have small blue dots representing about the size of a pea, and with negative lines drawn through them because they're negatively charged particles. and they're attracted to the positively charged electric charged particles of the protons in the nucleus. So if we just focus on the nucleus, which I'm circling in green, you see 2 positive charges and 2 neutral charges for the neutrons. So the net is 2 positive charges, and you can see that the nucleus is positively charged, which is right in the definition, a net positive charge. Now if we look at the atom as a whole, we see that there are 2 positive charges in the nucleus and 2 negative charges in an orbit around the nucleus. So 2 positive plus 2 negative equals 0, or net, no charge, no net charge. So let's return back to this definition of the proton, whereas the special definition as the nucleus of a hydrogen atom. So here we have an atom which is just in the nucleus is going to be a proton, and then surrounding it in an orbit is going to be an electron. Remember, for an atom, the net charge has to be 0. So since we have a proton in the nucleus, then we have to have an electron which is negatively charged in an orbit going around the nucleus. So when we look at a periodic table is just a table of atoms, more commonly referred to as a periodic table of elements. So when you hear the word element, think atom. So when you hear the word element, think of the word atom. Now notice that the periodic table is arranged in increasing number. So you have number 1 over here, then number 2 on the right, then 3, 4, 5, 6, 7, 8, 9, 10, and so on. That number is called the atomic number. Now it's important that you remember what the atomic number means. Atomic number is the number that you see in the top of the box, and it is the number of protons in the nucleus. So when you hear atomic number, think the red ball with the black plus symbol, and you're counting up the number of balls with plus symbols, which are going to represent the protons. So the atomic number is the number of protons in the nucleus. Now let's look at the atomic mass number, or the atomic mass. So the atomic mass is the mass of the total number of protons and neutrons in the nucleus. So there's your atomic mass. So in this example, the atomic number is 11, so we have 11 protons that are in the nucleus, but the atomic mass is 22.99. So instead of seeing the atomic mass, sometimes we see the atomic mass number. So the atomic mass number is a round up of the number that you see in the atomic mass. So since we see 22.99, we round it up to 23. So the atomic mass number is 23, which is the total number of particles in the nucleus of protons and neutrons. And since the atomic number tells us there are 11 protons in the nucleus, and the total number is 23, so 23 minus 11 gives 12, so there are 12 neutrons in the nucleus. So in this particular example, we see that there are 11 protons in the nucleus and 12 neutrons in the nucleus. Let's do another example. Let's look at number 1 in the periodic table, which is hydrogen. Now, number 1 in the periodic table is very special because it's different than the rest of the other atoms on the periodic table. Number 1 is the only one that has a proton in the nucleus and no neutrons. All the other atoms on the periodic table have neutrons in the nucleus, but not the hydrogen atom. It only has a proton. So if we look at the atomic number, we see 1, telling us there is 1 proton in the nucleus. And then if we look at the atomic mass, we see 1.008. In this case, we round down. 1.008 rounded down is 1, which happens to equal the atomic number, and therefore there is 0 neutrons in the nucleus, as expected. Now, for this atom to be neutral, total neutral, we know that there has to be the same number of electrons as equal to the same number of protons in the nucleus. If there's 1 proton in the nucleus, then there has to be 1 electron orbiting the nucleus. and there's our electron. Let's do another example. Let's go look at helium, or number 2 on the periodic table. The first thing we look at is the atomic number, which is 2, and that is telling us there are 2 protons in the nucleus. The next number we look at is the atomic mass, which is 4.003, and we round, in this case we round down, and we get 4. If the atomic number is 2 and the atomic mass number is 4, and we subtract, we get 2 left, so there are 2 neutrons in the nucleus. And since the atom has to be electrically neutral, we know that there has to be electrons orbiting the nucleus, and so we draw an orbit, and since there are 2 positive charges in the center or in the nucleus, there must be 2 electrons orbiting in the orbit. So let's go ahead and put our electrons in. And there we have the orbit of the helium atom. Now what happens when you have a situation where you have more electrons or less electrons, or fewer electrons than the number of protons in the nucleus? We call this an isotope. We call this ionization. So ionization is the process in which atoms lose or gain electrons. And thus an atom that has lost or gained 1 or more electrons is called an ion. Let's look at the hydrogen atom as an example. In the neutral hydrogen atom, we have a single positively charged proton in the nucleus surrounded by a negatively charged electron. There's 1 proton in the nucleus surrounded by 1 electron in an orbit around the nucleus, and the net electrical charge is 0 or neutral. Now, an ion is an atom that has gained or lost 1 or more electrons. So let's add an electron to this atom. So here I added a second electron to the orbit of the other electron. So now we have 1 positive charge in the center and 2 negative charges in the outside or in the orbit, and it has a net -1 electric charge. So it's not 0 as net, so it's not going to be an atom anymore, it's going to be an ion because this hydrogen atom has gained an electron. So this is one way in which you can gain an electron, gain an ion, or you can convert your atom into an ion. Let's look at another way. Let's go back to our original hydrogen atom, and this time let's lose the electron. So now here we have a positively charged nucleus with no electrons in an orbit around this atom. So the net charge is not 0. The net charge in this case is +1. So it's positively charged. And so we can't call this an atom anymore. We have to call this an ion. So keep in mind when you hear the word ion, it means it has gained or lost 1 or more electrons from its neutral state, from its atomic or atom state as it sits on the periodic table. So instead of adding or subtracting electrons, what if we added or subtracted neutrons? Well, this would be an isotope. So an isotope is an atom that has the same number of protons but a different number of neutrons. So let's go look at the difference between atom and isotope. And once again, let's go use the hydrogen atom as our example. So the hydrogen atom is electrically neutral, which we have in this case, and it has a single proton in the nucleus followed by an electron in its orbit. So we call this a hydrogen atom. But what happens if we add a neutron to the nucleus? So here we added a neutron to the nucleus. So now we have a proton in the nucleus and we have a neutron, and so the net charge of the nucleus is still positive, and we still have that single electron in an orbit, and so the entire what we see here is going to be electrically neutral. But we can't call it a hydrogen atom anymore because the hydrogen atom does not have a neutron in the nucleus. So we have to call this an ion. So this would be a hydrogen ion. So this would be an isotope, or specifically a hydrogen isotope. And this particular configuration has a special name. It's called deuterium. Deuterium is an isotope of hydrogen in which the nucleus contains a proton and a neutron. So this particular hydrogen isotope has a special name called deuterium. So when you hear the word deuterium, think of a hydrogen atom, but it's heavy. It's got an extra particle in its nucleus. So instead of one bowling ball being in the nucleus, you got two bowling balls in the nucleus. Now what happens when you combine atoms from the periodic table? Let's say you wanted to bind a hydrogen atom with an oxygen atom, and let's put in an extra hydrogen atom in there as well. What would you get? Well, you would get a molecule. A molecule is two or more atoms bonded together. And in this particular example, we wanted to combine a hydrogen atom with an oxygen atom with another hydrogen atom. What do we get? Well, let's draw the hydrogen atom as one big brownish green blob. So instead of putting that red center nucleus of a proton surrounded by that blue ball negative electron, we're just going to combine it all into this brown fuzzy blob and call that a hydrogen atom. For the oxygen atom, we'll do the same thing, and we will give it a gray blob, gray circular blob. And because the oxygen atom is so much heavier than the hydrogen atoms, I drew it larger. So here is our molecule. We have got an oxygen in the center, surrounded by or connected with two hydrogen atoms, and the connections are called bonds. Since we have two hydrogen atoms and one oxygen atom, commonly referred to as H2O, we have the molecule called water. And this is an example of a molecule.